Hello everyone, myself Dr. Deepa Bevingidar, working as Associate Professor in S.G. Palakundri Institute of Technology, Belagavi. In this video, we will be studying linear differential equations with constant coefficients. So these equations are very much important in electrical, mechanical and other linear systems. And also they play very important role in unifying mechanical and electrical oscillatory problems. So what is linear differential equation? Linear, the word itself says one. So linear differential equations means the equations containing dependent variable and derivative of it with degree 1 and they are not multiplied together. Such equations are called as linear differential equations. So these linear differential equations are denoted as dny by dxn plus p1 dn minus 1 y by dxn minus 1 plus p2 dn minus 2 y by dxn minus 2 plus so on. Pn y is equal to some function x, where p1, p2 up to pn are all functions of x. This equation is called as linear differential equation. Now we are studying linear differential equation with constant coefficient. It is clearly mentioned that it is a constant coefficient. So the same equation, if we write like this, d1y by dxn plus a1 dn minus 1 y by dxn minus 1 plus a2 dn minus 2 y by dxn minus 2 plus so on. Last term an y is equal to phi of x, where a1, a2, a3 and so on up to an are all constants. Coefficients are constants here. Such equation is called as linear differential equation with constant coefficient. So this is of nth order. Degree is 1. So such equation is called as linear differential equation. So here order of this equation is n. Now we are going to study such type of equation and solution. What are the rules? These equations play very important role in electrical and mechanical problems. These are very much applied over there. So now this is linear differential equation. This equation is very important. Then how to solve such equations? For solving such equation, we use one notation that is called as differential operator. What is a differential operator? We denote this operator by capital D. What is this differential operator? Differential operator means we write in place of d by dx is equal to d square by dx square is equal to d square and so on. dn by dxn is equal to d raised to n, so that dy by dx becomes dy, d square y by dx square becomes d square y, and d raised to n y by dny by dxn becomes d raised to n y. So this d is called as differential operator. So substituting these in equation 1, we get in place of dny by dxn, it is d raised to n y, a plus a1 d raised to n minus 1 y and so on up to a n y is equal to phi of x. So y is common, I will take y outside, so we will get this one. So this is function of d. I denote it as f of d. It is function of y, function of d, y is equal to phi of x, is equal to phi of x. So this is the representation of linear differential equation. and d is assumed as it is a algebraic function. So by using the regular factorization methods, we can solve this equation. We'll get roots. So here one more thing is important. So order of this is n, then here constants will be n. Constants will be n. In the solution, we'll get the constants, those will be n. So suppose if one equation is there, this is the considered equation. If suppose it has solutions like y1, y2 up to yn. These are the solutions of this equation. Then we represent this solution as y is equal to c1 y1 plus c2 y2 plus so on cn yn. This will be our final answer. Always we should write the final answer like this. So these are the constants. C1, C2 up to Cn are called as arbitrary constants. If it is equation, quadratic equation, then we'll get 2 constants. If it is cubic equation, then we'll get 3 constants. So always number of constants is equal to order of the equation. And in the solution, introducing constants is very important. You have to put the constant and they are linearly dependent. We have to write down the answer like this. Now we'll solve or we'll find out what are the rules to find the solution for this. To study the solution, so we'll consider one simple quadratic equation, generalized simple quadratic equation. By comparing that, you can find the solution for any order linear differential equation. Let us consider one equation as d square plus a1d plus a2y is equal to phi of x is equal to phi of x. It is quadratic equation. In this one, suppose phi of x is equal to 0, then this equation is called as linear differential equation with homogeneous linear differential equation. Suppose phi of x is not equal to 0, then it is called as non-homogeneous linear differential equation. Now we'll study first homogeneous linear differential equation. So phi of x is 0. If it is homogeneous, that is phi of x is equal to 0, then we have to find out only CF. CF means it is a complementary function. Its solution will be only complementary function. Suppose if it is non-homogeneous, that is phi of x is not equal to 0, then its solution will be y is equal to yc plus yp. Yc means it is a complementary function, yp means it is particular integral. So if it is non-homogeneous, we have to find out complementary function as well as particular integral. So now we'll study first homogeneous linear differential equations and how to find the solution. First we'll study rules. What are the rules to write the solution? So here we have considered second order, that is quadratic differential equation. If it is quadratic, then we'll get 2 roots. Let the roots be m1 and m2. Okay, so m1 and m2, these are the 2 roots of the equation. Nature of the roots will be 3 types of roots we'll get. One is real and distinct. Real and distinct. So these are the nature of the roots. Second possibility is real and equal. Real and equal. Third possibility is imaginary. So we'll get only these 3 types of equation, types of solutions, that is roots. So suppose real and distinct means m1 is not equal to m2. Then what is the solution? Then its complementary function is yc is equal to c1 e raised to m1x plus c2 e raised to m2x. This is the solution. So for this one example, suppose the roots are 2 minus 3. one equation is there, its roots are 2 minus 3. Then how will you write complementary function? We write complementary function as yc is equal to c1, m1 is 2, e raised to 2x plus c2 e raised to minus 3x. This is the solution or complex complementary function. Suppose roots are 1 by 2 minus 7 by 3. Then yc is equal to c1 e raised to x by 2 plus c2 e raised to minus 7x by 3. In this way we have to write the solution. So this solution, if it is order 2, we will get 2 constants and 2 roots. If it is of nth order, then yc will be c1 e raised to m1x plus c2 e raised to m2x plus so on cn e raised to mnx. In this way we get the solution. Next, if roots are real and equal, that is m1 is equal to m2, they are equal, say m, then its complementary function is yc is equal to c1 plus c2x e raised to x, c1 plus c2x e raised to mx. Okay, suppose again one example we will take 2, 2. These are the roots of the equation. Then we write yc is equal to c1 plus c2x e raised to 2x. In general, yc is equal to c1 plus c2x plus c3x square plus so on cn x raised to n minus 1 e raised to mx when roots are real and equal. Third one, when roots are imaginary. Say roots are in the form p plus or minus I q, where p is the real root and q is the imaginary part. Then how to write yc? Yc is equal to, so this is real part, e raised to px c1 cos qx plus c2 sin qx. Here also we have 2 roots, one is p plus iq, other one is p minus iq. So this part is very important. In almost all the types of solving linear differential equations with constant coefficients, first we need to find out the roots and write the complementary function. If it is non-homogeneous also, first we have to find out yc. That's why these 3 are important. When roots are real and distinct, roots are real and equal, and they are imaginary. Now we solve problems based on this. How to solve homogeneous linear differential equation and how to find the roots, how to write the solution for that. So already examples are written here. Directly we will take roots just to practice how to write complementary function. So what is the nature of first root? It is imaginary. So then it is of type 3, that is third type. That when roots are imaginary, its yc will be, what is the real part here? Real part is 3 and imaginary part is 2. Yc is equal to e raised to 3x c1 cos 2x plus c2 sin 2x. So this is the solution of first one. And second one, I will write the solutions here. So second one, how many roots are there? There are 4 roots. How many constants you have to put? You have to put 4 constants. That you have to decide when you solve the example and how many roots you will get. Based on that, so it is, there are 4 roots. So 4 constants will be there. And then what is the nature of the roots? All roots are real and they are distinct. They are different. So how to write yc? Yc is equal to, for first root, c1 e raised to x plus c2 e raised to minus x plus c3 e raised to 2x plus c4 e raised to minus 2x. Then for third one, How many roots are there? So here just observe C1, C2, C3, C4, 4 constants. How many roots are there? Again 4 roots are there. 4 constants should be there in the solution. What is the nature of the roots? All are real and one is distinct and these 3 are same. So for this one we have to write the solution. Next for these 3 we have to write the solution. For this one, yc is equal to c1 e raised to 0 into x plus, here 3 roots are equal. For that one, c1 plus c2x plus c3x square e raised to minus 2x. Anyhow, e raised to 0 into x is 1. So it is c1 plus, here it should be c2, c3, c4. c2 plus c3x plus c4x square. Always take care that the constant, same constant should not repeat in the solution because their values may be different. They are arbitrary constants. So don't repeat the same constant. Next, fourth one. How many roots are there? 1, 2. This is 1 plus I, 1 minus I. So 4 roots are there. These 2 roots are similar and these 2 roots are imaginary. For this one, yc is equal to equal roots c1 plus c2x e raised to x plus, this is imaginary, so c3 e raised to, real part is 1, e raised to x, c3 cos x plus c4 sin x. It is e raised to px. P means here it is 1. Cos qx. Q is also 1. So c3 cos x plus c4 sin x. Last one. How many roots are there? Here also 4 roots are there. But roots are similar. That is 1 plus 2i, 1 plus 2i. 1 minus 2i, 1 minus 2i. They are similar. So yc is equal to, real part is 1, e raised to x, c1 cos 2x plus c2 sin c1 plus c2x cos 2x plus c3 plus c4x sin 2x. This is the solution. Suppose here this one, c4x square, c1, c2 plus c3x plus c4x square. Again one more root is there, then c5 x cube will come like that. So this is very important. Just try to understand how to write the roots, and depending on the nature of the roots, how to write complementary function and those 3 types, and just take general roots and try to write on the solution. Now we'll take exactly the problems. Now we'll solve some examples on this. So this is y double dash minus 6y dash plus 13y is equal to 0. First write down by using differential operator, that is capital D. Y double dash means a d square minus 6y dash means 6d plus 13y is equal to 0. It is homogeneous, so only complementary function. Then we have to write auxiliary equation. Auxiliary equation. What is auxiliary equation? Just we consider the coefficient of y and factorize it to find the roots. So here it is m square minus 6m plus 13 is equal to 0. So to find roots of this, directly you can use calc and you will get direct answer. So for this one, roots are 3 plus or minus 2i. Better you find it with calc, easily you will get. So roots are 3 plus or minus 2i. So we have yc is equal to 2 imaginary roots are there. How will you write the solution? This is real part and this one is imaginary part. So it is e raised to 3x c1 cos 2x plus c2 sin 2x. c2 sin 2x. It is the solution. Next we will consider one more example, that is m cube plus 6m square plus 11m plus 6 is equal to 0. So in your calci till cubic equation easily you can find the roots directly. Here roots are m is equal to minus 1, minus 2 and minus 3. These are the roots. So what is the nature of the roots? Nature of the roots, they are real and distinct. Always check, it is cubic equation, you should get 3 roots. When 3 roots are there in the answer, 3 constants will be there. So yc is equal to c1 e raised to minus x plus c2 e raised to minus 2x plus c3 e raised to minus 3x. So these are the simple examples I have considered. Now we'll solve some lengthy problems on this. So next example, 4y triple dash plus 4y double dash plus y dash is equal to 0. Then we'll write by using operator, differential operator, 4d cube plus 4d square plus y dash means it is dy is equal to 0. Then auxiliary equation will be 4m cube plus 4m square plus m is equal to 0. So roots are 0, minus 1 by 2, minus 1 by 2. So here 3 roots are there and 2 roots are equal. All 3 roots are real. So yc is equal to c1 e raised to 0 into x means c1 plus these 2 roots are equal. So we have to write c2 plus c3x e raised to minus x by 2. This is yc. Next example, that is fourth one, d cube y by dx cube plus y is equal to 0. So by using differential operator, it is d cube plus 1 y is equal to 0. Then auxiliary equation will be m cube plus 1 is equal to 0. And roots of this equation are m is equal to minus 1, 1 plus or minus 3i by 2. I repeat, these answers directly you will get in calci. Directly you put in equations and you will get the answer. So here 3 roots are there. One is real and other 2 roots are imaginary. So yc is equal to c1 e raised to minus x plus, here real part is 1 by 2, imaginary part is 3 by 2. c1 e raised to minus x into plus e raised to 1 by 2 x into c2 cos 3x plus c3 sin 3x. c3 sin 3x. So in this way you have to write the solution. Then we will consider next example, that is fifth one. So fifth example, when till cubic equation easily you can solve in calci and write the answer. If it is of order 4, then how to solve? I'll take one example, that is d4y by dx4 plus 4y is equal to 0. First you write down in terms of d, that is d raised to 4 plus 4y is equal to 0. Then auxiliary equation is m raised to 4 plus 4 is equal to 0. These equations you cannot solve directly by using calci. In such cases, what we have to do? We have to make adjustment. That is m raised to 4 plus 4 is there. So I'll write this one as m square plus 2 whole square. Take square root of this, square root of this. So m square plus 2 whole square. What is the expansion of this? M raised to 4 plus 4 plus 4m square, that is 2ab. That 4m square is extra here. So I'll subtract that. 4m square is equal to 0. This is the adjustment you have to do. Then here it is m raised to 4 plus or else m square plus 2 whole square minus this one we can write as 2m whole square is equal to 0. Now it is in the form a square minus b square is equal to a plus b, a minus b. It is in this form. So I'll write this one also as m square plus 2m, I'll write in order, plus 2, 1 bracket, and other one is m square minus 2m plus 2. Now we have got two quadratic equations. Again use calci and find the answer, that is find the roots of this. So roots are 1 plus or minus I, minus 1 plus or minus I. You can check with calci. These are the roots. Then how to write the solution? Yc is equal to, again it is of order 4. You will get 4 constants and 4 roots are there. First we will write for this one. All 4 are imaginary roots. First we will write solution for this. It is e raised to p is 1 e raised to x, c1 cos x plus c2 sin x plus, here it is minus x, e raised to minus x, c1 c2 are over, c3 sin x plus c4 c3 cos x plus c4 sin x. This is the solution. Next, similar one more example is there. Similar to this, d raised to 4 plus 64 y is equal to 0. So this is similar to this. Here 4 is there, here 64 is there. Here also we write auxiliary equation. It is m raised to 4 plus 64 is equal to 0. How will you adjust this? You can write this one as m square plus 8. Its square root is 8. Its square. So what is extra here? M raised to 4 plus 64 plus 16 m square is extra. So I will subtract that. Is equal to 0. Again we can write this one as m square plus 8 whole square minus 4m whole square is equal to 0. Again we will do by using this. So this is similar example. I hope easily you can solve this. Next we will consider one more example. So next example is 4d raised to 4 minus 4dq minus 23d square plus 12d plus 36 y is equal to 0. Here we cannot adjust the terms and even we can't use calci to find the roots. In such cases, how to solve it? First we will write auxiliary equation. Auxiliary equation will be 4m raised to 4 minus 4m cube minus 23m square plus 12m plus 36 is equal to 0. Okay, so we have to find one root by inspection. What is by inspection? By inspection means randomly we have to put some value. If that value satisfied this equation, then we take that one as the root of the equation. So first you put m is equal to 1. Always take smaller numbers. If you put m is equal to 1, what you will get here? If you put m is equal to 1, so it is 4 minus 23 plus 12 plus 36. Is it equal to 0? This is not equal to 0. Then m is equal to 1 is not a root. Next you put m is equal to 2. You can check with calci. Just substitute here m is equal to 2. What is the answer? Just take the answer. It is 0. It will be satisfied. Then we take 2 as the root by inspection. You check this one. Definitely will get 0. So m is equal to 2 is the one root. Then we have to find out remaining 3 other roots. So for that one we use synthetic division method. What is synthetic division method? You have studied in your 10th and PU also. What is synthetic division method? I will explain here. In this one we have to take the coefficients of the given equation in descending order. If any coefficient is not there, in that place you have to write 0. Here all the coefficients are there. Directly we will take 4 minus 23, 12, 36. Then By inspection, first root is 2. So take m is equal to 2 and here 0. This is the rule. You have to apply the same rule for all the problems. So here 4 plus 0, it is 4. Then multiply these two. 2 into 4 is 8. Minus 4 plus 8 is 4. Then multiply this one. 2 into 4 is 8. And minus 23. 8 is minus 15. Then minus 30. 12 minus 30 is minus 18. Again minus 18 into 2 minus 36. Here always you will get 0. That you have to observe. Always you will get 0. Now this fourth order equation reduces to cubic equation. Then by using these coefficients we can write 4m cube plus 4m square minus 15m minus 18 is equal to 0. For finding roots of this equation, you can use calci. By using calci, your answers will be m is equal to 2 minus 3 by 2 minus 3 by 2. So already we have one root. Then finally we have 4 roots, those are 2, 2 minus 3 by 2 minus 3 by 2. So 2 roots are equal, they are real. So yc is equal to c1 plus c2x e raised to 2x plus c3 plus c4x e raised to minus 3x by 2. This is the complementary function of this rule, this problem. Similarly, they may give other problem. Then also one root by inspection, then by synthetic division method. So we will take one example when initial conditions are given. So solve d square x by dt square plus 5 dx by dt plus 6x is equal to 0, and conditions are given here. Given x of 0 is equal to 0 and dx by dt is 0 when t is equal to 50. When t is equal to 0, dx by dt is equal to 50. Initial conditions are given. So here when initial conditions are given, we can find out the values of arbitrary constants. First, as usual method we have to apply d square. In here parameters are different. In place of x and y, x and t are given. Only that is the difference. So we will write by differential operating term d square plus 5d plus 6x is equal to 0. What is auxiliary equation here? Auxiliary equation is m square plus 5m plus 6 is equal to 0. And what are the roots of this equation? Roots of this equation are minus 2, minus 3. Then we will write solution. 2 roots, they are real and distinct. c1 e raised to minus 2x. Here we will use y only. Here x, it is in terms of x. X is equal to c1 e raised to minus 2t plus c2 e raised to minus 3t. This is our complementary function. Now we will use given conditions to find out c1 and c2. What is the first condition? First condition is x is equal to 0 when t is equal to 0. So we will substitute this in equation 1. 0 is equal to c1 e raised to 0 is 1, c1 plus c2. Let this be equation 2. Next condition is dx by dt is equal to 15 when t is equal to 0. So here dx by dt is given. So we will differentiate equation 1 with respect to t. Differentiating 1 with respect to t. What we will get here? Dx by dt is equal to differentiation of e raised to minus 2t is minus 2 e raised to minus 2t minus 2 c1 e raised to minus 2t and this one minus 3 C2 e raised to minus 3t. Now we'll substitute the conditions. This is 15 is equal to, this one will be 1 minus 2c1 minus 3c2. Let it be equation 3. Now 2 and 3 are two simultaneous equations in terms of c1 and c2 are the unknowns. So by solving simultaneous equations, again you can use calci, we'll get solving 2 and 3, we get c1 is equal to, c1 is 15 and c2 is equal to minus 15. Now we'll substitute these in equation 1. Therefore from 1 or substituting in 1, we get x is equal to, c1 is 15 e raised to minus 2t minus 15 e raised to minus 3t. So this is the solution. When initial conditions are given, then c1 and c0, c2 values can be found out. So this is about method and what are linear equations with constant coefficient and all. Here what we have to do, first check whether given equation is homogeneous or non-homogeneous. If it is homogeneous, find out only yc. To find out yc, find the roots. Roots is equal to order of the equation, okay, and order of equation is same as number of constants. Then find the nature of the roots. Depending on the nature of the roots, write down yc. This is the method you have to apply. So thank you. If you like my video, like, comment, share and subscribe.